Recording. All right, so a week ago, I introduced different kinds of technologies for seeing very small things. So various kinds of microscopy, like light microscopes, electron microscopy. We talked about different staining methods, things like fluorescence and so forth. Most of this course, as you know, is about utilizing the data from these different kinds of imaging technologies to create highly realistic images of different kinds of structures, everything from the anatomic level down to the cellular level, down to the molecular level. Unfortunately, at the cellular level, there's not really a whole lot of data that you can bring into our popular graphics programs, like into a 3D program, or even generate a reference to bring into Photoshop or Illustrator or something like that. So light microscopy, you have the images themselves, you have the light micrographs, they're called. With electron microscopy, you have the electron micrographs, the images themselves from these different kinds of microscopy. But you don't have like any kind of 3D data that you could convert into some other format and maybe bring into Cinema 4D or Maya or something like that. One of the only things at the cellular level where you can access that kind of three-dimensional data and actually bring that data into a popular graphics program is with Cryo-ET. So cryo-electron tomography, that is basically cryo-electron microscopy. And as a reminder, that's just electron microscopy performed at very cold temperatures, which increases the electrical conductivity of the sample, which allows you to get finer resolution of your images. So you take cryo-electron micrographs, which are individual cross-sectional slices, and then you stack them together to create a three-dimensional image. Very similar to the way Horos takes a bunch of cross-sectional slices from CT or MRI, stacks them up to make a 3D model. Cryo-ET, cryo-electron tomography, takes individual cross-sectional electron microscope images and stacks them up to create something 3D. So that's what we're going to focus on today, is accessing the raw data from cryo-electron tomography and figuring out how to then convert that data into some format that's usable in a graphics program. And just in a nutshell, what we're going to do is I'm going to introduce you to a new application called Chimera X, which we'll use quite a lot for the rest of the semester, because it's also a very useful program for looking at molecules, molecular structures. But one big advantage that Chimera X has is that it's also a great program for viewing Cryo-ET data. So I'll introduce Chimera X. It's quite simple. It allows you to open the Cryo-ET data and apply a couple of little filters to it, and then export it as a 3D model, as an STL file, very similar to what we did in the segmentation exercise on Monday, where we exported images from Horos as an STL file. But then rather than simply rendering them in the program that we used on Monday, which was called, what was that again? MeshLab, sorry. Rather than just doing the quick renders in MeshLab, I'm going to introduce you to Cinema 4D. This will be your first introduction to Cinema 4D. Now, some of you may have used it before, but this will be the first time that I'm introducing it to you. So we'll actually do some more elaborate stuff with Cinema 4D. And specifically, the exercise we're going to do is we're going to make a virus. We're going to download a model for the spike protein on the surface of the virus. We're going to download that from an electron microscopy database using Cryo-ET data. convert that into a 3D model using Chimera X. And then we'll bring that spike protein model into Cinema 4D, and I'll show you how to distribute it randomly on the surface of a sphere to create our own coronavirus model. Now, the first couple times that I did this particular exercise, before the big coronavirus outbreak, we did exactly the same thing with Ebola. The Ebola virus looks like a worm, and that's it on the left. And just like coronavirus, it's covered with little spiky proteins, which allow the Ebola virus to actually bind to your cells and infect your cells. So when I used to do this exercise, I would have people download the Ebola virus spike protein, and then we would draw a little worm in Cinema 4D, and then scatter this spike protein all over the surface of the Ebola virus. So now we're going to do exactly the same thing, but since, you know, coronavirus is so near and dear to everyone's heart, we're going to go ahead and do that too. And so the image that we're going to create is going to look kind of like the one on the right, which hopefully reminds you of that red spiked ball coronavirus image that was all over the media during the pandemic. Now, this is my version of that, but it uses the exact same technique that Dan Higgins and Alyssa Eckert used at the CDC to create their version that literally went viral, pun definitely intended at that time, and became, you know, this infamous image that was associated with the pandemic. So like I say, that's my version of it on the right, but it's created exactly the same way that Alyssa and Dan created theirs, where they retrieved a model of the spike protein from an electron microscopy database, and then simply scattered it randomly on the surface of a sphere, and then just did some little tricks with rendering. I mean, theirs is maybe a little prettier than mine, but maybe a little. But it gets the point across. And you know, once you've done this in Cinema 4D, you can also animate it. So here's a different version that I created. And it's not the best animation in the world because it has a little hiccup. It's set to loop, and there's a little pause before it loops. And I know there's some little setting that I forgot to check that it would make it a more seamless loop without the little hiccup. But anyway, we're going to make something that looks kind of like that. All right, so let me show you how we're going to do this. So first thing is, we want to search an electron microscope database to actually find some 3D electron microscope or 3D cryo-ET data. And so I'm using something called the EM data resource, and the URL, if you can't read it up there, it's emdataresource.org. There are actually several different databases out there that are all pretty good that have this kind of cryo-ET data. And there are a couple different ways to search for these things. There are some various search tools under here, but we're going to just use the basic search feature. There's a little space in here where you can enter some search term. And before we jump right into the coronavirus, let me just show you some of the other kind of data that's in here. And I may have previewed this for you last week when I gave you the cell visualization lecture, but you know, you search for something like a ribosome, and this first page is limited to 20 entries, but there are probably hundreds of entries. Yeah, actually, if I look over here, there are actually 3,125 electron microscopy database entries that have something to do with ribosomes. They may not all be ribosome structure. They may have something to do with ribosomes, but you know, we can look at just 20 entries. We can look at 500 entries and just scroll all the way down here. It helps to know a fair amount of cell and molecular biology to be able to figure out which of these things is actually just a picture of a ribosome. Sometimes you have to read the names. So structure of a drug-like molecule called CDH1 ribosome nascent chain complex in rotated state with AAtRNA and PEtRNA. Okay. Again, helps if you know a little bit of cell biology to just be able to decipher what that even means. I can tell just from looking at the image that that is a ribosome, just because I've looked at so many of these EM database images of ribosomes that I know exactly what they look like. The one that's a little bit lighter, or the one that's a little bit blue in the background, is the large subunit of the ribosome. The one that's more white or gray back there, that's the large subunit. And the little orange and purple thing in there, those are two of the tRNA molecules that are actually bound to the small subunit. So I can tell just from these little thumbnails that that's a pretty good one. So if I wanted to download that, I could simply click on its little ID number. All of the Cryo-ET models that are stored here in the electron microscopy database will have a code number like this, so EMD dash something, and it's either a 4 or 5 digit number. So if I click on that, I get a little larger image where I can distinguish again the small subunit in the sort of light blue, the large subunit in kind of a light gray, 2 transfer RNA molecules in purple and orange. And then there's actually another little thing down here, this little purple string. That's actually a polypeptide chain, a protein chain that's being manufactured in the ribosome. I can download this 3D data by clicking on the download tab. And there are a number of different kinds of things that you can possibly download. I mean, you could just download a PNG file, which is just a 2-dimensional image. But if you want to be able to actually use this in a 3D program, what you want is the file that's called the primary map file. And that's going to be the ID number EMD underscore, in this case, 0599.map.gz. The GZ just means that it's a gzip file, means it's a compressed file. As soon as you download that GZ file to your computer, you can simply double click on it and it will decompress it. And so what you'll be left with is a file called EMD underscore 0599.map after you've decompressed it. I mean, I'll just do that real quick. Download the GZ file. While it's doing that, I'll open up my downloads folder. And it's still working on it. Surprised, it's actually not that big a file, but it's going kind of slow. All right, there it is. So I just double click the gzip file and it decompresses it. I can throw the gzip file away now if I want. And what I'm left with is just EMD, then the code number .map, and that's my 3D model file. So now I'm going to actually go after the coronavirus model, which is what we want for today. I noticed under the search tools that because the coronavirus is so incredibly popular, there's actually an enhanced search tool specifically for looking for coronavirus stuff, but you shouldn't have to do that. If I put in coronavirus, I'm going to get every single kind of coronavirus. So there was coronavirus 1, coronavirus 2, COVID-2, that's the one that caused the recent pandemic. But there's also MERS and SARS, severe acute respiratory syndrome. I forget what does MERS mean. Forget what that's an acronym for, but so there's a lot of different coronaviruses. So rather than searching just generically for coronavirus, I'm going to actually put in COVID-2. And I did this a couple days ago and was surprised. Even when I put in COVID-2, it still gives me things that are not COVID-2. Like over here in the upper left, the very first entry is a negative stain EM map of MERS-2. That's a different virus. Now here's something, the structure of replicating SARS-CoV-2 polymerase. That is a coronavirus type 2 protein, but what we're looking for is the spike. And there's a lot of these that are spike models, but you have to read the titles of them to make sure that that's all you're getting. To make sure, number one, that you're actually getting like the real coronavirus type 2 spike protein. But you also want to make sure that it's not like a spike that's in complex with some other molecule. Like this one right here, Cryo-EM structure of SARS-CoV-2 spike. Hey, that sounds pretty good. But then it says with an H11D4 nanobody complex. So it's actually bound to something else. The spike protein also has a couple of different conformations, a couple of different forms. Most of the time when the coronavirus is just circulating or just hanging out in a little ball of mucus or something like that, all of these spikes are in what's called a closed configuration. But as soon as that coronavirus gets close to one of your cells and it recognizes a protein on one of your cells called ACE2, which stands for angiotensin converting enzyme type 2. It recognizes that surface protein on your cells, and the spike then undergoes a conformational change to what's called the open configuration. And it has to be in the open configuration before it can then begin to bind to your cells. And then it undergoes a really bizarre transformation that we'll talk about some other time. But if we're just showing a coronavirus just kind of hanging out in a little blob of snot, or just free floating through the air, not actually binding to anything, we probably want to make sure that we choose one of these with a closed conformation. So this would be a pretty good one right here. If I scroll down, you'll find, I'm only looking at 20 entries. There are 2,119 entries. So even if I look at 500 at a time, there's still going to be more than 4 pages of these things. Let's see. So that first one probably would have been pretty good. That would have worked. Yeah, some of these others like Cryo-EM structure of SARS-CoV-2 spike protein bound to neutralizing SYN bodies. So that means it's actually bound to some other molecule. So we want to find the most basic one that's not bound to anything else. And I know I found a pretty good one just the other day. That first one up there probably would have worked fine. But since I'm scrolling down here, let me see if there's any other good ones down here. Yeah, a lot of these are bound to other things. Structure of coronavirus spike from a smuggled Guangdong pangolin. Wow, okay. So, I know what a pangolin is. That's the scaly anteater that some people think that the virus originally came from. Yeah, that's interesting. The a theory, and of course there's 20 theories out there, but a theory is that the bats got them from pangolins.
Oh, okay.
Right.
Okay, we found this on the web is that the bats got them from pangolins.
Sorry, Zoom people, but yeah, Siri apparently is listening to me. Yeah, so, or was it the other way around? Was it? Yeah, there seem to be lots and lots of variations of coronaviruses among bat populations. I think it's the other way around, that the bat gave it to the pangolin, and then the pangolins are sold at these wet markets where they sell lots of exotic animals. So that's a theory.
Yeah, that makes sense.
I'm going to use that one just because I think that's kind of fun. And I can tell just from looking at this thing that that is basically the same structure as the SARS-CoV-2 virus. But like I say, as long as you read the text and understand what you're getting, as long as it's the closed configuration and as long as it's not in complex with something else. I mean, here's one that's in complex with Billy Verdon, which is kind of interesting. So where'd my pangolin go here? Right, so I just know from having done this a bunch of times that that looks just like the regular old SARS-CoV-2 spike protein. So I'm going to go to the download tab and I'm going to select that primary map. And that one downloaded in an instant. I'm going to get rid of the other one so I don't get rid of the one that I downloaded earlier, the ribosome, so I don't get confused. So this is my spike protein, double click that to decompress it. And then get rid of the gzip file because I don't need that anymore. Right, so that's really all we need to do with the electron microscopy database. Like I say, just be aware that it's there and it's got a relatively simple, straightforward search function to just search for things by name. You just have to then sift through the results to find the one that you want. So now I'm going to open a new program you haven't seen before called Chimera X. And there's a couple ways to open this map file in Chimera X. You can simply go to the open menu, go to file and choose open. And then you have to navigate to it. So I need my folder, downloads. There it is. I can open it, or I could simply take the map file icon and just drag and drop it onto the Chimera X icon. That works too. But all right, so there is the spike protein, and rotate it around. I can use the scroll button, the scroll wheel to just zoom in and out on it. Now, if you look closely at this model, it looks a little different from the picture. You know, when I was in the electron microscopy database, there was a little picture, little thumbnail of the model. Looked a little different from this. But what we're looking at here is the raw Cryo-EM or Cryo-ET data for this spike protein. And I don't know if you recall me showing you some pictures from Cryo-EM and Cryo-ET a week ago when I was doing the microscopy lecture. There was a picture of a thing called a perforin, which is this protein complex that punches holes in cells. And the raw images themselves were very grainy. Even though Cryo-EM and Cryo-ET had pretty high resolution, they could see very, very small things. The images themselves are very fuzzy and very grainy. So there's a lot of noise in the images. And what you're seeing when you look at this model is that we're seeing Chimera's best attempt to render the model and decide what is actually model and what is noise. But when I open this thing in Chimera X, notice there's a little thing down at the bottom right, this little histogram image. There's a gray bar on there. I can slide that to the right or left. And if I slide it a little too far to the left, the whole screen goes gray. That's because we're now seeing all of the noise to the point that it's completely obscuring the model. If I drag it to the right a little bit, we see our model, and the farther I drag it to the right, we're seeing a little bit less and less of the model because it's hiding more and more of the noise. And at some point, it's probably hiding some of the model itself. So it's a little hard to know exactly how much detail is right. I know if I go too far to the right, then I'm just, the model's just disappearing. But somewhere in here is the appropriate amount of detail. What I found is usually when I first open these models in Chimera X, it chooses a pretty good value. So I usually just leave that little slider alone and just go with the default, which is what first happens when you first open it. So next thing I want to do in Chimera is up at the top, I'm going to click on the tab that says map. And this is a whole bunch of tools that are used specifically for working with this kind of Cryo-EM data, which is always saved in what's called a map file. And I'm simply going to click a button up here at the far right that says smooth. It's going to smooth out the map. And now we get a much smoother looking thing that doesn't have as much noise on it. And now in the bottom right, I've actually got two different little histograms. I've still got my original one that lets me change the amount of noise. But what I'm going to do is I want to make sure that I don't have all those little gray things poking through. And I can also play around with this little slider, which is going to modify the model a little bit. Once again, I usually leave that pretty much at the default level. But that's now a surface model of our spike protein. So from Chimera X, I can easily save this in various 3D model formats that I could then bring into another program. So I go to the File menu and I say Save. And I think I'll put this on my desktop. Maybe, all right, I'll just put it in the Downloads folder. That's easier. And I'm going to call this, I can call it anything I want. Spike protein. And then I want to choose the correct file format. And there's a lot of file formats to choose from in here. I can choose image file formats like GIF images or JPEGs. That's just going to export, a two-dimensional static image. I want to choose some kind of 3D format. And this one this one actually has Wavefront OBJ, which would be a great format if I was going to bring this into Maya. Not so good for Cinema 4D though. For Cinema 4D, I would want to save it either as a VRML, which is virtual reality modeling language, or STL, which stands for stereolithography, which is the standard format that's used for 3D printing. I know STL works fine. I mean, VRML will probably work fine too. Either of those formats will allow me to then open this in Cinema 4D. So just click Save. And that's all we need Chimera for at this point. Really just a question of opening the Cryo-EM data, applying a surface to it, and then saving it in 3D format. So I can quit Chimera X. Now I've got my spike protein STL. Right, so now this is where it's going to get a little more complicated because I'm going to try to teach you a little bit of Cinema 4D. And I'll admit right off the bat, I'm not a big time Cinema 4D user. I use it for molecular visualization, molecular modeling, and that's pretty much it. But hopefully I know enough that I can troubleshoot any issues that you might be running into and show you how to do this stuff. So in the applications folder, there are actually two different versions of Cinema 4D installed in these computers. There's Maxon Cinema 4D 2023 and 2024. There is a huge difference between these two, particularly in terms of rendering engines. And I am completely clueless about 2024 because it just came out and I haven't had a chance to figure it out yet. So I'm going to ask you to please use Cinema 4D 2023, which looks and behaves just like the older versions that I'm more accustomed to. So open the Cinema 4D 2023 folder and simply select Cinema 4D. And you can close this little welcome window that pops up. All right. So there's a lot going on here. We got a lot of tools and menus and windows and things. On the far left are some of our selection and transformation tools. Not too different from like Photoshop or Illustrator. We have lasso tools and marquee selection tools and things like that. So we've got some various selection tools up here. We've got things like a move tool and a rotate tool and a scale tool that let you move and rotate and scale objects. Up at the top, we have some tools that allow you to choose what part of an object you're actually acting on. So there's one that lets you select individual points, vertices on a model. There's one that lets you select just edges of a model, one that lets you select polygons or faces of a model, and then one that lets you select an entire model. There's also one here that lets you select the axis of a model, the central axis of a model. I'm gonna keep that unchecked for the time being. Over on the right, we have a couple of really important panels. There's an objects panel in the upper right. This is where you can see sort of a hierarchy of the objects that are present within your scene that you're working on. And in the bottom right is an attributes window where if you select a certain object, you can see all different kinds of features or attributes of that feature. At the bottom is an animation timeline. This is a simplified view of the timeline. There's also a more elaborate view of the timeline. If I click on this little thing over here, this little diamond, we get a bigger timeline view, but we don't need that because we're not animating anything in here. And there is one other window that I need to open, which does not pop up by default. Let's see. There's a couple ways to view it. If you look in the upper right corner of my main window, you see there's little XYZ axes. And then right above that, there's a little hand thing, which is move camera, scale camera, orbit camera, toggle active view. Then right above that, there's this little circle. And if I hover over it, it says Material Manager. I'm going to click that, and that opens up another little panel here, which is my Materials Manager. If that's hidden, another way to bring that up is I go to the window menu, and under the window menu, I can also choose the Materials Manager, and that opens that same window. So there's a couple of different ways to activate that Material Manager window. So let me open the spike protein, and then I'll show you a couple more things like how to move and navigate around in the viewfinder here, or in the camera view. So to open our spike protein, we're going to go to the file menu. We're going to say open project. And then I'm going to go to my downloads folder, and I'm going to choose the STL file that I exported earlier, that I created just a few minutes ago. Now it's going to ask me for some import settings for the STL. By default, when you do this, it'll probably come in and it'll say 1. Whoops, not 001. Oh, come on. When you open yours, it'll probably say 1. I like to scale the spike up a little bit when I bring it in. I'm going to scale it up by about a factor of 10. Just makes it a little easier to see and a little bit easier to work with. I'm going to click OK. And there's our spike protein imported. And if you look in the upper right, you see in our objects panel, there is actually now something in that list, in that hierarchy, called spike protein. And it recognizes that this is a polygon object called spike protein. I know that sometimes when I open these models, the axis, the XYZ axis for the model is not actually lined up with the model itself, which can cause lots of really weird things to happen later on. So later, when we apply this spike protein to the surface of our sphere, we may have to scale or rotate it a little bit. I find if the axis is not lined up with the model itself, it can be troubling. It can create issues. So I'm going to try to show you how to move that, but how to move that axis so it lines up perfectly with the model. But first, I got to show you how to navigate around here. There are a couple different ways to do this. Just to the upper right of the 3D image window or the camera window, we have that little hand, the move camera, the scale thing that looks like an arrow coming towards us and an arrow going away from us. That's a scale camera. And we have the orbit camera. One way to navigate around in here is to click on that hand and click and drag. And if I click and drag up, it drags the window up. If I click and drag down, it drags it down. With the scale camera thing, similar thing, I click on that arrow and drag down and it scales out. I click on the arrow and drag up, it scales in. And then the orbit camera, if I click on that and rotate, I can rotate around in 3 dimensions. It's honestly, it's a little awkward to keep going up to these three little icons here in the upper right. You can change from one to the other. So you can go from move to scale to orbit by simply holding down the 1, 2, or 3 keys on the keyboard and then using your mouse. So without having to go up there to the upper right corner, if I hold 1 and click, I can move. If I hold 2 and click, I can zoom in and out. If I hold 3 and click, I can now orbit around. Now, as I do that, I can see that there's a little XYZ axis, a little green, red, and blue axes sitting on a plane in the middle of, or in my environment here. That is actually the central axis for this model. And I'm not 100% sure why the axis doesn't normally come in with the model itself. So what we need to do is we actually need to select that axis and move it to so it's actually centered right in the middle of our molecule. So to do that, I want my move tool active on the far left. So the thing with the 4 arrows on my far left, that's my move tool. And then up here at the top, I want to click this thing that looks like an XY axis, which enables the axis of an object, of any selected object. And then I'm actually going to select my spike protein object in my object panel here in the upper right. So I'm just going to click on the name spike protein. It highlights the word spike protein in yellow to tell me that my spike protein model is active. But since I clicked on the enable axis tool, the thing that looks like an XY axis up here, anything that I move or rotate or modify is actually going to modify the axis of the model. It's not going to actually modify the model itself. So I can now grab these blue or red or green arrows and move my axis around and reposition it. Now, right now, it kind of looks like I just put the axis right in the middle, but I know from experience that it's not really in the middle. I have to kind of rotate my view around. So I'm going to click the 3 and rotate and click the 1 and move. And I can see that, oh yeah, I didn't really put the axis in the middle of the model. So I got to grab the green or the red arrow, grab the blue arrow. Just have to keep kind of moving around. Another way I could do this is I could open up 4 windows at a time so I could see it from the front, back, top, left, right, etc. at the same time. But but you do typically have to move these things around quite a few times. And it's surprising, you look at it in one way and it's like, oh, you're sure it's right smack in the middle. But then you move it again and you realize, oh, it's actually not right in the middle. If you're interested, I mean, there may be a better way to do this, which is up near that move, scale, and orbit camera, right up near those buttons, just in the upper right of the window. There's this other button, if you hover over it, it says toggle active view. You click that and you actually get a top view, side view, front view. And so in here, it actually might make it easier to position this thing right smack in the middle, because you see it in these three different orthographic projections. So then I can tell in the top view, it's right in the middle, the front view, it's right in the middle, and the right-hand side view, it's right in the middle. And then I can click that same toggle view button. Whoops, that's not what I want. I want to click in here. Oh, that's right. There's a new toggle view button that's associated with each of these four panels. I need to click the correct one. And we go back to this, my 3D view. But now I know my axis is lined up dead center with the model itself. Right, so before I forget, now I'm going to turn off that enable axis tool up here. I'm going to just click again on that thing that looks like an XY axis to make sure that I don't inadvertently pick up my axis and move it again. All right. It would be nice now to maybe put a color on this thing, because right now it's just kind of dull gray. So this is where my materials manager is important. That was that extra window that I had you open here, this extra panel. So just to remind you, it's this little circle icon up here. You just click that to open this materials manager, or alternatively, go to the window menu and select material manager, and it gives you this blank panel here. There's a couple ways to create a new material. This is to create a new surface texture. I can click the create button and just say create new default material. And it gives me this little sphere. The other way is simply click the plus sign, and same thing, gives you a new default material. I can edit the attributes of that material down here in the bottom right, or I find it easier to double click on the material, and it brings up this material editor window. And over on the far left-hand side of my materials editor are a bunch of options, things that you can apply to the materials, and only the things that are checked are actually turned on. So right now there's a checkbox next to the word color and a checkbox next to reflectance. So that means that this object is going to have a color. I haven't given it a color yet, but it'll have a color as soon as I put one on it. It's going to have some kind of reflective properties, some kind of lighting properties. So I'm going to click on the word color in that list, and I see over here on the right, I have some options for changing the color. By default in Cinema 4D, it comes up with this H, which is HSV, hue, saturation, and value. It's kind of like the Adobe color picker, where you choose colors by first picking the hue, then the saturation, then the value or brightness of the color. My brain doesn't work that way. I honestly, I wish they had CMYK as an option because my brain thinks in CMYK. But short of that, I'm going to click on the R, which is going to at least let me create colors in RGB. My brain can kind of think in RGB a little bit. So if I play around with these RGB sliders, I can specify different colors. And I'm going to pretend that I'm Alyssa and Dan at the CDC, and I'm going to put red spikes on my coronavirus. But have fun, and if you want to put bubblegum pink spikes on a lavender virus, you know, and make it look not so threatening, that's entirely up to you. So that's, you know, I can play around with colors in here all day. I can make something really hideous like that, or, you know. So after I've chosen an RGB color for my spike protein, the only other thing I'm going to edit in here is reflectance. So reflectance is checked, so it's turned on, but I need to actually click on the word reflectance to activate it, to bring up our reflectance options. And by default, it brings up a very simple type of reflectance editor, I guess you could call it, or simple sort of algorithm for determining the shininess and surface properties of the model. It's bringing up what's called a specular Blinn type of reflectance. You know, that works okay. I played around with a bunch of the options under here, and you've got things like Phong, which is kind of a really basic sort of old renderer for giving things a sense of form. I kind of like GGX personally. I've kind of gravitated towards that. So I'm going to change this from Blinn to GGX. Feel free to play around with the others if you want. But now I have a bunch of settings under GGX. I've got something called roughness. That's my first setting. And right now, by default, it's set to 50%. So that's really just what the name suggests. It's a way of defining how rough the surface texture of my model is going to be. If you have something that's very rough, it means that it's not ever going to give you a shiny specular highlight. So think about something like a tennis ball, right? A tennis ball that's covered with fur is never, ever going to have a glistening, shiny, metallic looking highlight, because all that fuzz on the tennis ball breaks up the light beams and scatters them around, so you never get a distinct highlight. On the other hand, something like a metal ball or a shiny plastic ball is completely smooth on the surface, has like no roughness, and that's why it has such a gleamy, shiny, specular highlight. So you control the hardness of the highlight basically using this roughness setting. So watch what happens to the little preview when I drag that all the way up. I get like no highlight. That's my tennis ball. It's very rough on the surface. And the opposite is if I drag it all the way down to 0, right? I don't know why it didn't give me any highlight. Oh, probably because I need to play with some of the other settings, but notice here, you know, when I've got my roughness down to like 20%, we're getting a very crisp, distinct, shiny highlight. So it's really up to you where you set this. Just recognize that the lower you set this number, the more shiny your spikes are going to look. I'm going to go somewhere in the middle, I think, in here. The next setting is reflection strength. And this is going to define if the spikes will literally have reflections on them. Are the spikes going to reflect the rest of an image of the rest of the virus? Are the spikes going to reflect the neighboring spikes so that you can actually see reflections in them? If I set this way up high, if you look at the preview, you'll see that You know, you're actually seeing reflections of like the checkerboard on the bottom of the ball. And if I also reduce my roughness, you see that reflection. I don't think I want that much reflectivity on the spikes themselves. The spikes are going to be very small once we apply them to the surface of a sphere. So I don't really care if they're going to be real reflective or not. So maybe I'll put just a teensy bit of reflectivity in them, you know, 15 or 20% or something, which might just create a little bit of visual interest, but they're not going to be, you know, super reflective. It's not like I'm going to have a lot of little mirrors, like a little disco mirror ball, you know, all over the surface of my model. Specular strength is going to determine just how strong that specular highlight is. If I go way up, we get just this crazy highlight that's just completely blown out. You know, you can't see any detail in there. If I go down to 0, still get a little bit of a highlight, but not nearly as strong. I'm going to give this a little bit of specular strength, but not a lot. The last thing is bump strength. Now, this only does anything if I've applied a bump map to my model. Do you guys do bump maps in Maya? Yeah, okay. I kind of figured you probably did. I'm not planning to create a bump map for my spike. So even if I leave bump all the way up at 100%, it's not going to do anything because I'm not actually creating a bump map. But just in case, I'm going to go ahead and turn it all the way down to 0. It doesn't affect our preview at all because I haven't actually created a bump map for this thing. So, you know, feel free to play around with these settings. I'm just going to go with what I have here and see what happens. And I guess right up under the color preview, there's a space I can actually give this material a name. So I'm actually going to call it spike and close it. Seeing this out now, you see it shows up here in my materials manager, and it's called spike, and we see a little preview of the properties of it. In order to apply that to my model, there's a couple different ways to do that, but what I find the easiest way to do is make sure that you've actually selected the spike material. If I click out here, I've deselected it, but I want to make sure that I've selected the spike material in my materials manager. Make sure that the protein model itself is also selected in my objects panel in the upper right. So you see how the word spike protein here in the upper right is highlighted in yellow. And then in the materials manager, there's a menu called material. Just click apply. And so now it applies that spike color texture to my spike protein.
Where do you find apply?
Under the material menu. Yeah, there's like 3 different ways. You could simply drag the material over onto the spike protein model, or onto the spike in the objects panel. All right. Right, so next thing I'm going to do is one of these things in graphic software. It's kind of like working in Illustrator, where you've got to do 6 different things that don't look like anything. And then finally you do like the last thing, and all of a sudden it's like, oh, okay, that's what that looks like. I'm going to create something called a cloner, which is what is going to allow me to repeat my spike protein all over the surface of the sphere. Now, I haven't created a sphere yet, so I'm not going to actually be able to apply the cloner to anything yet. I'm just going to go ahead and create the cloner, and then it'll become obvious later what that's going to do. So there's a menu here in Cinema 4D called MoGraph. There's also some little MoGraph objects over here, like this little guy. This thing that looks like a hexagon with little green balls at the corners. But I usually just use the menu up here. I'm going to go to the MoGraph menu. I'm going to say make a cloner. And you'll notice over on the right that a new object has appeared in my objects panel. There's a cloner object. With Cinema 4D, and I suspect probably a lot of this is true with Maya as well, a lot of the effects that you create with different objects depends a lot on the hierarchy of which object is like a parent, which object is a child of a different object. What I want to do is I want to say, all right, I'm creating a cloner, and the thing that is being cloned is this spike protein. So to do that, what I'm going to do is I'm going to take the spike protein object and actually drag it into the cloner. And you'll see that the spike protein now falls under the cloner in the hierarchy. And what you're seeing over here on the left in my image window is it still has all of the default clone settings. So it's just creating a whole bunch of copies of my spike. But I'm going to change some settings for my cloner. And let's see. I need to actually select the cloner in my hierarchy up here. I need to change the mode. So with the cloner object selected in the objects panel up at the top right, down in the bottom right now, I have all the attributes of that cloner. Under object properties, I'm going to change the mode from grid to object. And it just vanishes, but that's okay. It'll come back eventually. And I want to change the clones setting here, pop-up menu, from iterate to random. And it's still invisible. That's okay. It'll come back eventually. Right now I'm going to just deselect the cloner. I'm just going to click in blank space up in my objects panel. And so nothing is selected. And it looks like my spike has vanished, but it'll come back. What I want to do now is I want to create the virus itself. I want to just create a big sphere in the middle of my scene. And under the create menu, I can create a mesh and make a sphere, or alternatively over here, there's a menu with a cube on it. I can go in here and whoops, don't do that. And create a sphere over here. So it creates this little teeny tiny sphere. And right now that sphere is much smaller than the spike that we had originally. So I need to make my sphere bigger. So there's a couple of ways I could do that. The simplest is to grab the scale tool on the left. And with the scale tool, I can simply grab any of these little box handles on the axis and drag them in any direction. And it'll make a big sphere. Simply reposition that in the middle of my screen. What's that?
I see the value of radius is set to.
Yeah, let's see, where is that? Sphere. Yeah, where is that? Yeah, okay. 4729. I mean, this is approximate. I'm gonna end up scaling the spike a little bit proportionally later, but yeah.
Here, what it's. Like, it's kind of like. I don't know how to explain it.
Yeah, I've run into that before too. It's like you get to a certain point and it,
Yeah.
a certain magnification and it just hides.
But is there, okay.
But I don't know exactly why it does that.
That's okay.
Right, so before I start putting the spike protein on the surface of the sphere, I want to also change some of the surface attributes of the sphere itself. Give it some color and some texture and so forth. So I'm going to create a new material. So again, in my materials manager, I can go to the create menu or just click the little plus sign here and create a new default material. And I can double click that to open up the materials manager. And once again, I'm going to click the color setting here to give it a color. And, you know, I've got that red spike protein. I'm going to pick something that's kind of contrasting with that. You know, again, I could try to emulate the CDC one and make it kind of gray. I'd like to add just a little hint of blue in there, a bluish color, you know, whatever color you want. Like I said, if you want to make it bubblegum pink or you know, any color you want. I'm going to select reflectance again, like I did before, and I'm going to change this from specular to GGX. Roughness is probably fine. I can probably leave that about where it is. And reflection strength, I might actually make this a little bit more reflective. Although I'm going to put a bump map on it, so it may not really reflect very much. I'm going to leave the bump strength. Well, I think maybe I'll drop the bump strength down a little bit. I am going to put a bump map on so that I want some bump strength in there just so the bump map is visible. Now to create the bump map, to put some texture on this thing, I've got another setting here on the left called bump. Right now it doesn't have a checkbox though. If I could edit this bump map all day long, but if I don't check the box, it's not going to show up. So I have to check the box next to bump map to actually apply it. And now I'm going to choose some kind of texture for this thing. And you can play around in here. Basically what I'm trying to do is I'm trying to simulate the appearance of a lipid bilayer from the outside. Because the virus is actually enclosed in a lipid bilayer, just like all of your cells. So I want to create some kind of pattern of little dots on the surface of this thing that kind of looks like we're looking at the phosphate heads on the outside of a lipid bilayer membrane. So one that I've played around with before, one that I used in the examples that I showed you at the beginning of the demo, was noise. And you can see that we've got this kind of noise pattern on the sphere. It's a little hard to tell exactly what that's going to look like on the sphere. I can click the noise button here and I can get even more attributes for noise. I can scale the noise and lots of settings. I haven't had time to go through and explore what all of these different settings do. The main one that I play around with is just the scale, how big the noise is relative to the sphere. I think I'm just going to leave that for now and come back and change it later because I can't really see a preview of it yet. So I have to see what it looks like and then I'll know, okay, do I want to scale it down? Do I want to scale it up? So let me just give this thing a name, call it virus, and close it. So, and then I want to apply that material to the sphere. So I could simply drag the material onto the object, or I could drag it up and put it next to the word sphere up in the upper right. So I tell you what, it's 3:14. Why don't we take a short break, take 10 minutes or so. I'll come back and I'll show you the final steps in actually applying the spike protein to the surface of the sphere. Okay. Share screen again. All right, so now the really important step for getting that cloner to apply to the surface of the sphere, to distribute copies of the spike protein all over the surface of the sphere. I'm going to select the cloner object from my objects panel in the upper right. And I'm going to look down at the attributes in the bottom right. And the object tab down here in the bottom right should be selected. If something like basic or coordinates or transform or whatever, if those are selected, make sure to click the objects tab down here in the bottom right. And again, make sure that you've selected cloner in your objects panel in the upper right. So to get that cloner object to scatter all over the surface of the sphere, what we do is we're actually going to take that sphere object from our objects panel in the upper right. We're going to drag it down into this blank space that says object down here. Basically, that's telling it to apply the cloner to the surface of that spherical object. So I'm going to select the word sphere here in the upper right, drag it down and drop it into this blank space. And if you look over on the left now, you see that we've got a bunch of spike proteins laying on the surface of the sphere. But there's a problem with them. They are literally laying on the surface of the sphere on their sides. They are not sticking straight out from the surface the way they're supposed to. And to change that, we want to keep our cloner selected. We're going to go down to transform. And you've got a bunch of XYZ and HPB and more XYZ things. On the left, the P, this controls the position of the cloner objects relative to the sphere. The R values, notice those are degrees, those are angles, that controls the angle of the cloner object relative to the sphere. And over on the right, we can change the scale. So I think what I probably need to do to get these spikes to rotate into their correct position, I know this just from trial and error, but you can enter different angles in these three different spaces. Just from having done this before, I'm pretty sure it's the RP. And if I put 180 degrees in there, no, it just flips them. Sorry about that. 90. Now they're upside down. Well, actually, what's happened is I've rotated them 90. And now if I put 180 in, now it'll rotate them. It'll flip them 180 degrees around. So each time I enter a new value in there, it's applying it to whatever the previous value was. Okay, nope, that's not right. What the hell? Minus 90? That looks better. It's a little trial and error, apparently. I thought I knew exactly how it would work. But so in my case, minus 90, but if you put in some other number, you may have to keep changing until you get the spikes to stand up. So the fat part is sticking out and the skinny part is facing in.
Supposed to be like super in surface.
No, we're going to change that in a minute.
Okay. I was like, I don't remember.
Yeah, these spikes are embedded into the sphere too much. So we need to actually move them out a little bit. And that I'm pretty confident I know. We're going to change PZ in that transform area. Z is referring to the Z axis. So we're simply going to increase PZ a whole bunch. And if I just hold down on the little arrow and just keep holding it, the spikes are moving out from the sphere just a little. So I'm up to 500 centimeters and pretty close. Now, I'd have to, if I was creating this for something like the CDC, I would probably want to sit down with some researchers and figure out, all right, exactly where does the spike protein sit? You know, which part of it is actually embedded in the lipid bilayer on the surface of the sphere. But this looks pretty close to what I recall it looking like. Now, I think these spikes may also be just a tad big. So I can also adjust their relative size in my transform tab down here. I want to change X, Y, and Z, the SX and SY and SZ. That's size X, size Y, size Z. I want to change them all proportionally. I don't need to reduce them a whole lot. Maybe, I don't know, down to about 80%, but since it starts out with 1, so I want to put in like 0.8, 0.8, and 0.8. That's going to scale them all proportionally, about 80%. Of course, I realize now that I've done that, I've made them all smaller. Now they're sticking a little too far out of the surface, so I'm going to sink them back in to the surface just a little bit. Just about like so. Maybe that looks pretty good. Now, once again, if I was doing this professionally for the CDC or for anybody really, I would want to do some research to find out about how many spikes are on the surface of a typical coronavirus. And I'm sure that's well documented. I do feel like what I have right now is a little sparse. So I want to increase the number of clones on my sphere. And I do that by, I keep the cloner object selected in the objects panel in the upper right. But now I'm going to click object down here in the bottom right. And down at the very bottom, I have a count, which tells me how many repeats of the spike are on the surface. So I could increase this a little bit at a time, and you can see that they're starting to fill in and populate more. One problem that I've always had with this is that I feel like it puts them very densely clustered in some areas and has hardly any in some other areas. So one possible way to deal with that is to just literally move it around until it looks like the right number, give or take. Just kind of rotate around until it looks about right. Something else you can do, right above the word count, down in the bottom of our attributes, there's something called a seed. It's a seed number. Right now it's 1, 2, 3, 4, 5, 6, 7. Cinema 4D and probably every 3D modeling program that has some kind of random function like this uses a mathematical tool called a random number generator. And it's basically a mathematical algorithm that spits out sort of more or less random results. But you can change those random results by changing the input numbers. In other words, you enter a number into the random number generator, and then it spits out some, random string of numbers after. So by changing the seed number, it's going to completely change the distribution of these spikes. Each time I click the seed number and change it, it just totally redistributes these things. So to get these spikes to distribute very uniformly around the surface, sometimes you have to just keep hitting the seed number until they look like they're kind of uniformly distributed. Sort of like that. Now, there was something I was playing with this weekend, which I ended up watching a bunch of YouTube videos to see if I could figure out really how it worked. It was not behaving quite the way it seemed like it should work based on the videos that I watched. But you might also notice, in addition to having these spikes kind of clumped up in some areas, kind of sparse in some other areas, some of them are literally overlapping and intersecting with their neighbors. And that definitely should not happen. You shouldn't have things like these two. I mean, those aren't too bad. Those are not really touching, but I think there's a cluster of them here where there are several, at least two, that are literally overlapping one another. So there's yet another feature in Cinema 4D that might fix this. I'm going to try it and see if it works. I'm going to make sure that I keep the cloner object selected like it is right now. I'm going to go back to my MoGraph menu. And there's a sub-menu here called Effector. And there's an effector called Push Apart, which should create almost like a little force field around each spike so that it won't intersect its neighbors. And it did something. Yeah. Just telling me that those objects are active and visible.
Oh, that, it doesn't mean I'm stuck.
No,
Okay.
no.
Thank you.
So it doesn't seem like they've completely pushed apart from their neighbors. Maybe they, no, those almost look like they're intersecting still. So within that push apart effector, we do have a push apart radius. And I'm just curious if, yeah, if I click on that, if it pushes them apart more. Yeah.
Is that some of them like detach from the surface?
Oh, okay.
So
So in other words, they were pushing so hard that it literally pushed them off the sphere.
they don't just move.
Yeah.
Oh. but
So-
can you change- Can I be able to change like if it moves along the z-axis, the
Mhm.
z-axis or y or x, maybe that would.
Yeah, maybe. So since I just learned about this over the weekend and only had a chance to watch a few videos, I don't know what some of the other settings will do here. I mean, push apart, I don't know, along X. That didn't really do anything along Y. I don't think we want to push them apart along the Z because that'll, I mean, it's not, none of these are really doing much of anything. I don't know what changing iterations will do. Doesn't seem to do anything. Well, I think that's an improvement still over what we had originally. I think most of them are, there's still some that look like they're overlapping a little bit. Yeah, was gonna see what would happen if I also created a few more of these, if they would continue to intersect, or if it would. Yeah,
I wonder if you put the push apart effect on when you only had like 3 or 4. And
Mm-hmm.
then if you added them on, if they would automatically count.
good question. Well, I'm going to move along with the rest of the demo. And, once I turn you guys loose to just work on this a little bit on your own, I'll continue to play around with this. Like I say, it doesn't seem to work as seamlessly as it did in the YouTube videos that I watched. They seem like, I watched a YouTube video, they say, oh, just drag in this push apart thing and voila, it'll work just fine. Well, I wonder if it needs to be right above the cloner. No, that doesn't seem to matter. Sometimes, again, the order of the arrangement of things in your objects panel can have a big effect. But so what I want to do now is add some lights to my scene so that I can start rendering it. So I'm going to add a light, and there's this sort of objects toolbar just to the left of my objects panel. And down at the very bottom is a little light bulb icon. I'm going to click that and add just a light. And this is going to create just an omni light, which is a, fairly basic light that illuminates in all directions. Now it put that light right smack in the middle of my sphere. So it's not illuminating anything. I need to move it out of the sphere. Over on the far left in my selection and transformation tools, I still have the scale tool selected. So I don't want that. I want to be able to move my light. So I need to switch to my move tool over in the left. And then I can pull that light out of the sphere, bring it towards me, move it up a little bit. I'm putting it in the upper left, for kind of our standard upper left-hand lighting. And I actually want to change some of the attributes of that light. So I'm going to click the light in the upper right in my objects panel. And I get a whole bunch of settings down here. Under general, I could actually change the color of the light source. Right now, it's a pure white light. If I wanted to give the light a little tint, like if I made it a slightly yellowish, that would be kind of like an incandescent light bulb. But something that I definitely want to do is I want this light to be able to cast shadows. And right now, by default, it's going to light up the objects, but it's not going to create any shadows. So once again, with the light selected in my objects panel down here under all of these different attributes, there's actually a little menu for shadows, little pop-up menu. And I'm going to change that from none. I'm going to choose Shadow Maps Soft for my shadows. I could turn on what are called ray traced hard shadows, but these have like an absolutely hard edge to the shadows, which I think looks really unnatural. So I find that the soft shadow maps create more realistic looking shadows. And then I'm actually going to modify those shadows a little bit. With the light object still selected in my objects panel, down here under the attributes, there's actually a whole tab for shadows. And I can do things like change the density a little bit. Right now, by default, the shadow density is set to 100%. What that's going to do is it's going to give me a 100% solid black shadow, which is also not very realistic. Shadows are rarely are they like pure black. And they often have like a little tint of color to them.
Of your shadows.
I don't have, I haven't rendered anything yet, so we're not actually seeing. We're just setting it up as one of the attributes of the light. So I'm going to reduce the shadow density a little bit down to maybe 85%, which is a little more realistic. And I can even change the color of the shadow by clicking on this little colored box. And shadows are rarely pure black. They're usually more little brownish. So I'm going to just put a little bit of color in here to make a little bit of a brown shadow. Almost a little purpley. And one other setting that I find useful to change, there's a thing here called shadow map. And right now it's set by default to 250 by 250. This setting is going to change the hardness of the edge of our shadow. I mentioned before that the ray traced shadows have a perfectly crisp hard edge, which is just completely unrealistic. Shadows don't normally have like a really crisp hard edge. They're usually kind of soft and fuzzy a little bit. But I find the default soft shadows to be a little too soft. It's like the other extreme. Changing this to a larger number is going to give us a little bit harder edge shadow. Even just changing it to say 500 by 500. Honestly, I don't know what those numbers mean. I just know that through trial and error, a higher number for the shadow map is going to give us a little bit sharper shadow that I think is a little more realistic. So I've created that one light, which I placed in the upper left. It's 100% strong light. I gave it a teeny bit of a yellow tint, and I added these soft shadow maps. Generally, when you're rendering, I imagine you probably did a little bit of this with Glenn in Maya, is you typically want like a secondary light source, like what's called a fill light. Because if you have just one big spotlight shining on something, you're going to get a really bright side to that object, and then everything in shadow is going to be completely invisible. So the fill light is something that's often placed on the opposite side. So I've got one light that's in the upper left. I'm going to create another light and put it down the bottom right to serve as a fill light. So I'm going to create a second light from my toolbar here. And once again, I have to pull it out from the sphere. I'm going to pull it out in front just a teeny bit, but then pull it down below, so it's kind of in the bottom right as opposed to upper left. And I'm going to change some of its settings over here on the right. I know something that a lot of photographers do. You see it sometimes in fine art pieces where there'll be kind of like a fill light, but it's actually got a little bit of a color to it. I like to make my fill light a little blue or a little sort of blue greenish color. So I'll play around with that here in my RGB settings. The fill light also is not nearly as strong as the primary light. So I'm going to reduce the intensity of this other light down to something much smaller, I don't know, 30 or 40%. So it's not nearly as bright as my primary light. And I'm not going to have shadows. I'm going to keep the shadows set to none, because I want the shadows to come from the upper left from my primary light. I don't want shadows to come from the from this other fill light in the bottom right. So we are close to being able to render now. And before I actually render, I want to edit some of my render settings. So there's a render menu up at the top, and there's a setting to edit the render settings. So there's a few things that I want to change in my render settings. For one thing, I want to change the output size because there is a, well, this is kind of buried in the instructions for today's exercise, but similar to the previous assignment or the anatomy assignment, I want something that's 8.5 by 11 at 300 pixels per inch. So we have to tell it to render the image at that size. And so in my render settings under output, I'm going to click this little triangle at the top, and I'm going to choose a preset. I'm going to choose a print landscape preset. So something that's oriented in landscape view. I mean, this is a sphere, so it really doesn't matter if you do it in portrait or landscape mode. But I'm going to choose letter size. So print either portrait or landscape, choose letter size. So that gives us something that's 11 by 8.5 inches, and it automatically enters 300. Now it does, I hate when software does this. It uses a misnomer. It says pixels per inch, and then in parentheses it says DPI. Not DPI, it's PPI, it's pixels per inch. DPI is dots per inch. That means something completely different in the graphic arts business, but whatever. Right, so make sure that your image is 8.5 by 11 at 300 pixels per inch. Under options in my render settings, there's only one thing I need to include in or change in here. There's a setting in the first column here called default light, and by default, the default light is turned on. I've never quite understood this with Cinema 4D. So when you first create any scene in Cinema 4D, it has default lighting, so that if you do like a quickie render of something, it actually has this default light so that you can kind of see what you're working with. But it seems to me once you add lights to the scene, you would think that the lights that you've added would take over, and it would actually use the lights that you put in the scene. Not so. Cinema 4D will continue to use the default lighting. You can add 17 lights to your scene, and Cinema 4D will ignore all of them and just continue to use the default lighting, unless you turn this off. So you have to uncheck that default light box to get it to actually utilize the lights that we created in the scene. The only other thing that I like to do in here is I like to add an effect, and there's a button for effects down here in the bottom left of our render settings window. I like to add ambient occlusion, which I find makes nicer renders. I just leave those settings by default, but I like to turn on ambient occlusion. So I can close that. I'm gonna zoom in on my virus sphere here a little bit, just so it fills most of the window. And then what I like to do for rendering is under the render menu, there's something called render to picture viewer, where you can just hit Shift R on your keyboard. And what that does is it renders the scene in another window. And I can tell right off the bat that the bump map that I created on my sphere is just looks ridiculous. So I need to scale that bump map quite a bit. It looks kind of cool, but it's doesn't look anything like a cell membrane. So I'm going to stop this. So I need to double click my material, go to my bump map, want to reduce the global scale quite a lot. I'm going to go down to 10%. I might have to go even smaller. Now let's try that again. Shift R to render to picture viewer. That looks better. I mean, it may not really look like a lipid bilayer, but it definitely looks like some kind of little speckly thing. And you can see the cast shadows. You can see a little bit of reflection of the red spikes on the sphere. That's because I gave the sphere a little bit of reflectivity. And you can see that the spikes are actually reflecting a little bit of the color from the sphere. You can see a little bit hint of blue in the spikes where they're reflecting the sphere. So that's basically how that works. And so once I've done this in my picture viewer, I need to save it. So I go to the file menu and say save image as. And I'm actually going to have you save it as a TIFF file, which is the default. So it's going to save it as a TIFF file, 8 bits per channel, 300 PPI, not DPI. And click OK. And then I think it'll ask me where to put it. There we go. So now I can tell it where to place that and put it on the desktop. So I should have a TIFF file on my desktop up there. And I could open that, whoops. Open that Photoshop, see what it looks like. There it is in Photoshop, and if I check my image size, it should be 8.5 by 11 at 300, which it is. At some point in Cinema 4D, you might want to actually save the Cinema 4D file to save all this work that we just did. So I could say, save project. If I say save project as, it allow me to give it a different name. Spikeprotein.c4d works. So that way you can reopen the Cinema 4D file anytime you want. Keep playing with it. So why don't you all go ahead and give this a shot, and I'm going to keep playing with that push apart effector and see if I can figure it out. I am. Thank you. Probably don't need to record 20 minutes of silence. Thank you.